Very good afternoon, students. I hope all are doing good, staying safe at home. I guess you are all listening to the news every day. Keep watching the news and see how was the conditions around. So please stay safe, everyone in your house. Don't go outside unnecessarily. Concentrate on your studies and follow the classes regularly and send your assignments also regularly. So far we have completed two chapters, that is first lesson metallurgy and second lesson P block elements 1. And according to the syllabus, the next lesson we have to go for the month-wise syllabus, we have to go for the 6th chapter, that is solid state. So we are going to learn this chapter. We are going to start this lesson from today. First and second lessons are over. Kindly follow the study material which I have sent you. So once the lesson gets over, try to solve all the book back objectives, and you have any doubt, please contact me and learn the book back question answers also. So in this lesson, we will be learning about what are the general characteristics of solid, how they are classified into, and what does a unit cell mean, how they are packed, how the unit cell and the atoms are packed in the unit cell, and what is the packing efficiency for the different types of cubic unit cells, and few numerical problems and defects in solids. So we all know matter will exist in three different physical states like solid, liquid and gas. So if you look around, we can see solids more than liquid and gas. Solids are present everywhere than liquid and gas. So solid, they differ from liquid and gas by possessing a definite volume and definite shape. So obviously solid when compared to liquid and gas, they are having different properties because they are having a definite volume, that is a fixed, perfect and permanent volume and a perfect shape. In the solids, the atoms, the molecules or ions are tightly held in an ordered arrangement, and there are many types of solids like diamond, metals, plastics. So we have so many like this, and most of the substances that we use in our daily life are in the solid state only. So we require solids with the different properties for various applications, and understanding the relation between the structure of solid and their properties is very much useful. So how to synthesize them, how to prepare a new solid, for that we need to know the different properties of those solid materials. So that is what we are going to see in this chapter. We study the characteristics of solid, classification, structure and their properties. We also will see the crystal defects and their significance. So moving on to the general characteristics of solid. So already we have learnt in 11th standard that gas molecules, they move randomly without exerting reasonable force on another material. So they will move randomly. Gas materials, they will move randomly and they will have so much space in between each and every ion. So unlike gases, in solids the atoms are held together. So we can say either a single particle as an atom or an ion or a molecule, we can say. So always they are held together by strong force of attraction. That is why they are very rigid. So what could be the general characteristics? Solids have definite volume and shape. Solids are rigid and incompressible. Solids have strong cohesive forces, and solids have short interatomic and interionic distances. Their constituents have fixed position. They will not move from one place to another. They will have a fixed position and they can only oscillate about their mean position. So what are the classification of solid? So they are basically classified into two types. One is crystalline solid, the other one is the amorphous solid. Crystalline means perfect arrangement of atoms or ions. Amorphous solid means they are randomly arranged. The atoms or ions are randomly arranged. And these crystalline solids are further classified into ionic crystals. Examples we can say Na plus and Cl minus. So they are produce anion and cation. That is why they are called as an ionic crystals. And covalent crystals means they will have a covalent bond between them. And molecular crystals like naphthalene, anthracene and glucose, and metallic crystals, they are all metallic elements like sodium, magnesium, copper, gold, etc. And atomic solids are frozen elements of group 18. So atomic solids is something special. Frozen elements of group 18 we call it as that is helium, neon, oxygen, all they are atomic solids. So we can classify these solids into two major types based on their arrangement of their constituents. So if you see here from this part, general characteristics of solid could be asked in 2 marks, and that flow chart, this classification could be asked in 2 marks. Now moving on to the explanation of crystalline and amorphous. The term crystal comes from the Greek word crystallos, term from where that it comes, crystallos, which is a Greek word which means clear ice. This term was first applied to the transparent quartz stones, and then the name is used for solids bound by many flat symmetrical arranged faces. So how the solids are bounded by many flat symmetrical arranged faces. Next, if you see what is meant by crystalline solid, a crystalline solid, this is a definition you can see here. A crystalline solid is one in which constituents have orderly arrangement extending over a long range. The arrangement of such constituents in a crystalline solid is such that the potential energy of the system is at minimum. So இப்படி ordered arrange ஆயிருக்கிறதுனால their potential energy for a system is minimum. In contrast, they will have a more potential energy, which means in amorphous solids the constituents are randomly arranged. So this table was asked in the last midterm 5-mark question. So listen, crystalline solid, this could be this is a book back question. Listen, crystalline solid and amorphous solid, long range orderly arrangement of constituents, which means they are properly arranged. Short range, that is random arrangement of constituents. Crystalline solids, they have a definite shape, and amorphous solids, they have an irregular shape. Generally, crystalline solids are anisotropic in nature. They are isotropic in nature. So we'll see what is isotropy and anisotropy also. And these crystalline solids are true solids, but these amorphous solids, they are considered as pseudo solids or supercooled liquids. Definite heat of fusion for crystalline solids, and amorphous solids, they don't have a definite heat of fusion, and they have sharp melting points and gradually soften over a range of temperature and can be molded. So examples for crystalline solid, we can say NaCl and diamond, and for amorphous solids, rubber, plastics and glass. So let's see what is meant by isotropy. Isotropy means uniformity in all direction. So which means if you pass light or heat or anything, if you pass, they will pass in one proper direction, that is uniformly. Whichever direction you place the light to pass through the solid, they will move in a proper single uniform direction. That is what we call it as an isotropy. In a solid state, isotropy means having identical values. So wherever the position, if you want to measure in whichever the side you keep and measure the refractive index or electrical conductances or any physical properties, it will show the same answer in whichever the position you measure it. So we call it as an isotropy in all the direction. Whereas anisotropy, which means anisotropy, is a property in which depends upon the direction of measurement. That is, they will not show the same answer in whatever the direction. So crystalline solids are anisotropic, and they show different values of physical properties when measured along in different directions. So crystalline solids are anisotropic because they show different values which is measured along the different direction. The following figure illustrates. So anisotropy in crystals, they show different answer in different direction. Isotropy, they show the same answer throughout everywhere. And this classification of crystalline solids. So these crystalline solids are further classified. We saw first we have is ionic solids. The structural unit of anion and cations, we call it as an ionic crystal. They are bound together by strong electrostatic attractive forces. To maximize these attractive forces, the cations are surrounded by as many anions. So what do we have when we have an positive or negative ion, definitely there will be an electrostatic force of attraction. So these ionic crystals, mainly they are having only anion and cation, so they will have these attractive force, and they are surrounded by anions to have more attraction. The anions will be surrounded by cations to have more attraction. Same way, the cations will be surrounded by anions to have more attraction. Ionic crystal possess definite crystal structure. Many solids are cubic close packed. Example, the arrangement of sodium and chlorine ions in a crystal. So if you see here, the green ones are chlorine, the yellow ones are the sodium. So you can see this is how the ionic solid will look like. For example, NaCl they have shown. Characteristics of ionic solid, again 2-mark question. Ionic solids have high melting point and these solids do not conduct electricity. So when the possibility of electricity will come up? Only when there is a movement of an ions, we can say there is an electrical conductance. But these solids, we have the atoms or ions, they are fixed position, they are fixed in their positions, so they don't move their position, so they do not conduct electricity. But the ions are, because the ions are fixed in their lattice position, they do conduct electricity in molten state. So when do they conduct electricity? In the molten state, when dissolved in water, because the ions are free to move in the molten state or solution. They are hard as only strong external force and can change their relative position of ions. Next is covalent solid. In covalent solid, the constituents are bound together in a three-dimensional network entirely by a covalent bond. So that is why they are called as covalent solids. They have three-dimensional network by a covalent bond. For example, diamond, silicon, carbide, and such covalent network crystals are very hard and they have high melting point and they are usually poor, and their thermal conductivity and electrical conductivity are very poor. Next is molecular solids. In molecular solids, the constituents are neutral molecules. They are held together by weak van der Waals forces. Generally, molecular solids are soft and they do not conduct electricity. So what is the attraction in molecular solids? Weak van der Waals forces. And these molecular solids, they were further classified into non-polar molecular solids and polar molecular solids. So if you see, graphite is used in pencil, it slips easily off the pencil onto the paper and leaves the black mark because they are lubricants. For example, they are very commonly used as lubricants in bicycle chain oil, and because it is very slippery because of its weak van der Waals forces. Non-polar solids, that is non-polar molecular solids, if we see, in non-polar molecular solids, constituent molecules are held together by weak dispersion or London forces. So what is the force between them? Weak dispersion force or London forces. And they have low melting point and they are usually in liquids or gaseous state at room temperature. For example, naphthalene and anthracene. Next is polar molecular solids. The constituents and molecules are formed by polar covalent bonds. How they are formed? By polar covalent bonds. They are held together by dipole-dipole interaction. So each and every solid, they have a specific type of attractive force. So in non-polar solids we have London force. Here we are having dipole-dipole interaction because they are polar in nature. They have higher melting point than the non-polar covalent solids, and for example, solid CO2 and solid ammonia. And hydrogen bonded molecular solids, these constituents are held together by hydrogen bond. So what is an hydrogen bond? Hydrogen getting bonded to an highly electronegative atom give rises to the formation of hydrogen bond. They are generally soft solids under room temperature, and examples of solid ice, that is glucose and urea, are the examples. And metallic solids, if you see, you have already studied in your 11th standard about the metallic bonding. That is, in metallic solids, the lattice points are occupied by positive metal ions and the cloud of electric pervades, that is the space between them, will be charged by these positive metal ions. They are hard and they have high melting point, and metallic solids possess excellent electrical and thermal conductivity. As they are metals, they will have good conductivity and for heat and electricity. They possess bright luster because they are very shining, because their property is, lusting is the property of a metal. For example, metals and non-metals, metals and metal alloys belong to this type of solid. For example, copper, iron, zinc, gold, silver, copper zinc mixture. Crystal lattice and unit cell. So what does a crystal lattice mean? Crystalline solid is characterized by a definite orientation of atoms, ions, or molecules relatively to one another in a three-dimensional pattern. We call it as a crystal lattice. The regular arrangement of these species throughout the crystal, the proper arrangement of an units in a regular crystal, we call it as a crystal lattice. So the basic repeating structural unit of a crystal lattice, we call it as an unit cell. So something is going to be arranged repeatedly so that it gives rise to a crystal. So that basic repeated arrangement, we call it as a unit cell. So if you see here, so this whole part is a crystal. So that one highlighted part is an unit cell. So this basic repeated arrangement, we call it as an unit cell. So all together, unit cell all together joined together, we call it as an crystal, and all the corners we call it as an lattice point. The crystal may be considered to consist of large number of unit cell, each one in direct contact with its nearer neighbor and all similarly orientated in space. The number of nearest neighbors that surrounding a particle in a crystal, we call it as a coordination number of that particle. So 2 mark. The number of nearest neighbor atoms. So ஒரு யூனிட் செல்லில் எத்தனை ஆட்டம் சரவுண்ட் ஆயிருக்குன்றது, ஒரு யூனிட் செல்லில் ஒரு ஆட்டமை சுற்றி எத்தனை ஆட்டம் இருக்குன்றது தான் we call it as a coordination number of that particle. And a unit cell is characterized by 3 edge lengths or lattice constants like A, B, C, and their angle we call it as an alpha, beta, and gamma. So the 3 edge corners they have given as A, B, C, and the angle between them or the unit cell is alpha, beta, and gamma. Primitive and non-primitive unit cell. So these are the two types of unit cell, primitive and non-primitive. A unit cell that contains only one type of lattice point, we call it as an primitive unit cell. ஒரே type of lattice point இருந்ததுன்னா it is primitive. More than one type of lattice point இருந்தது அப்படின்னா we call it as an non-primitive. So if you see here, see the picture. So primitive is only one type. So if you see here non-primitive, more than one type of lattice points you are having, we call it as non-primitive. So there are 7 primitive crystal systems: cubic, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic, and rhombohedral. So they differ in the arrangement of their crystallographic axes and angles. Corresponding to the above 7 Bravais lattices, we have 14 possible crystal systems. So are you all clear what is primitive and non-primitive? Primitive means they will have a same kind of crystal lattice. Non-primitive means they have more than one additional type of lattice points. So if you see here, first we have is cubic, where A, B, C are equal, which means alpha, beta, gamma is equal to 90 degree. And rhombohedral means A is equal to B is equal to C, but their angles are not same, where alpha is equal to beta is equal to gamma is not equal to 90 degree. And hexagonal, if you say alpha is equal to beta is equal to 90 degree, but gamma is 120 degree. So all these will be asked in 1 mark objectives, and altogether they will ask you to draw in 5 mark or 2 mark or 3 mark. Tetragonal means alpha, beta, gamma is equal to 90 degrees, but their A, B is not equal to C. And orthorhombic, A is not equal to B is not equal to C, and their angles are equal. Monoclinic, A is not equal to B is not equal to C, and alpha, beta is equal to 90 degree, beta is not equal to 90 degree. And triclinic, anything is not equal to each other. So if you see here, these are the 14 Bravais lattices. Cubic is further classified into primitive, body-centered, and face-centered. So you can see here, primitive means only one type. Body-centered means there is one atom on the body that is at the center. Face-centered means all the 6. A cube will have 6 faces. So all the 6 sides of the faces in center, you will have one atom. That is face-centered. And tetragonal also has a primitive and body-centered. Body-centered, it has one atom in the middle at the body. And hexagonal, they have only one type. Orthorhombic, it has primitive, body-centered, face-centered, and base is face-centered means on the that is only on the top and bottom, not on the sides. Okay. And monoclinic, it is primitive and base basis face centered. Trigonal they have only one type, and triclinic it has only one type. So this table also they will ask mostly what are the different types, what are the other crystal lattice systems of orthorhombic. If they ask me, you must be able to write primitive, body centered, face centered and basis centered. So this could be asked in a 2 mark or objective also. So with this we'll stop today. So today we have seen the classification of solids and what are the characteristics of ionic solids, and what is the difference between ionic and crystalline solid, and what is meant by unit cell, and what is the type of units, are all that we discussed it today. Tomorrow we will see the number of atoms present in each cubic cell. So your assignment will be given today. Please complete your assignment and submit on time. Thank you.